Compact disc player. A compact disc CD is read from the bottom by a semiconductor laser with wavelength 790 nanometers, passing through a plastic substrate of refractive index 1.8. When the beam encounters a pit, part of the beam is reflected from the pit and part from the flat region between the pits, so these two beams interfere with each other. So part reflects from the pit and part reflects from the flat region between the pits. So we have the pits here and the flat region between the pits. So we have the light reflecting, going through this plastic substrate and reflecting from this interface. What must be the minimum pit depth? B, so that the part of the beam reflected from a pit cancels the part of the beam reflected from the flat region. It is this cancellation that allows the player to recognize the beginning and end of a pit. So we want these two beams reflecting from the pit and from this flat region to interfere so that they will produce destructive interference, a minimum. Okay, so if you look at the ray 1, which goes to the flat region and reflects back, and ray 2 that goes to the pit and reflects back, we have, due to the depth of the pit, a total path difference of plus d 2d forming between the two rays. So the path difference, that is the path followed by ray 1 minus the path followed by ray 2, when they come to interfere, is 2d. So ray 1 travels an extra distance of d 2d before coming back to the other side. So we have this must be equal to m plus 1/2 the wavelength lambda in air divided by n, because that's the wavelength in the plastic. So we have this plastic substrate with index of refraction n. The minimum pit depth, d minimum, will correspond to m equals to 0 here. That's lambda over 2, where lambda is the wavelength in the plastic substrate. So that's basically lambda over 2n divided by 2, that is lambda over 4n. So we have 790 nanometers wavelength divided by 4 times 1.8, that's the index of refraction, giving us a minimum pit depth of 110 nanometers. And that's how we find the beginning and end of a track on the CD. Okay, so we're talking about a compact disc player where we read from the bottom of the plastic substrate by sending a laser beam with a semiconductor laser of wavelength 790 nanometers. The plastic substrate has an index of refraction 1.8, and we look at the interference at a step here. So we have the pit and the flat region between the pits. So we have the interference of these two rays hitting this edge and giving us a minimum that basically gives us the beginning or end of a track. And if you look at the path difference between these two rays interfering on the other side, these two rays are coming at normal incidence, and so they will be meeting at the same point on the other side. So we will have destructive interference when the path difference that develops between the two, 2d, so that's for reflection, the incidence and retroreflection, giving us total path difference 2d, is equal to m plus 1/2 lambda, where lambda is now the wavelength in the plastic substrate, so that's lambda in air divided by n. So we find that the minimum pit depth will correspond to m equals 0, the first destructive interference, which is occurring at lambda over 4n for the minimum depth, and that gives us 110 nanometers.